Investigation of Curves, Section 4, Envelopes and Arc Lengths. Video 2, Arc Lengths, Cartesian Curves. Now in the last video, we looked at how to find an arc length for a curve defined parametrically. Now we're going to work through a similar method for a Cartesian curve. So here's my curve again, and this time I'm considering a short change in x, delta x, and a short change in y, delta y, in terms of delta x. So I'm in Cartesian, everything is defined in terms of x, so I can consider a small change in x, delta x. And once again, I've got my chord, which is approximating the arc length, which I've called delta s. So by Pythagoras, delta s squared is delta x squared plus delta y squared. Now I can consider what happens as delta x tends to 0. So I'll have delta s squared over delta x squared equals delta x squared over delta x squared plus delta y squared over delta x. And then as delta x approaches 0, this is going to become ds by dx all squared equals 1 plus dy by dx all squared. The 1 is coming from the fact that delta x over delta x is 1. So in the limit, this would be dx by dx, which by definition is 1. Then I can take the square root of this expression, and finally I can integrate to get s. So s is the integral of the square root of 1 plus dy by dx all squared dx. Let's work through an example. Find the length of the curve with equation y equals x squared between 0, 0, a squared. Well, if y equals x squared, I can work out that dy by dx is going to be equal to 2x. So using my formula, s equals the integral from 0 to a of the square root of 1 plus dy by dx all squared, so that's going to be 4x squared dx. Now I could work out this integral by hand, but I've got a computer algebra system, so I might as well use it. So first of all, I want x squared, and I want to know the derivative of x squared. So the derivative of expression 1. And now I want the square root of 1 plus the derivative expression 2 squared. And that gives me my root 4x squared plus 1. Computer algebra system has just written it the other way around there. And now I need to find the integral. So I put the integral, and I want it to be the expression 3 that I'm integrating, that square root. And the limits of my integral are from 0 up to a. And then it's given me this expression here. So I've got 2a square root of 4a squared plus 1 minus the natural logarithm of the square root of 4a squared plus 1 minus 2a all over 4. Let's have a look at how we would write this down. Well, in order to answer the question, I need to start by finding dy by dx. So I would write down dy by dx equals 2x. And then I put that into my formula. S equals the integral from 0 to a of the square root of 1 plus 4x squared dx. And then I just copy it straight down from the computer algebra system. S equals, and then it was 2a root 4a squared plus 1 minus natural logarithm of root 4a squared plus 1 minus 2a, and that was all over 4. So that's giving me the arc length in terms of a. In this video, you've learned how to find the arc length of a curve defined by a Cartesian equation.